Some symbols that are used in the reactions that you need to be familiar with. We have the arrow, which means yield, produce, make, or form. And that's when you're just taking the reactants and turning them into products. G would be for the gas state. If you were to produce a gas, sometimes you might see an up arrow used instead on the product side. S, we should know, means solid state, and if it's on the product side, then we would call that the precipitant. L is for the liquid state. Sometimes you'll see it as a cursive L. I know I like to write mine as a cursive L, so I'm not confused with the number 1. And really the only liquid that we worry about in here is water. So water is always going to be a liquid unless otherwise stated. Aqueous, we know, means that it breaks apart into ions in water. And then we have the plus sign. And if we were putting it into words, the plus sign, we would say and if it's on the product side, or if it's a reactant, or on the reactant side, we would say reacts with, dissolves in, mixes with, something along those lines to show you're putting them together. Okay, you have to be able to balance the reactions, and that's because of the law of conservation of mass. The mass that you start with has to equal the mass that you end with. So we balance our reactions in order to show that. So when you're given a formula, or when you're given a word equation, the reaction in words, you need to write the formula equation. So you're going to want to take your compounds and cross your charges, unless you see a prefix. And then there's a special group of elements called diatomics, and these are elements that exist as two atoms together when they're not in a compound. The way I remember them is by remembering the word Hofbrinkel. So hydrogen exists as H2, so it's two hydrogen atoms together, it's not one hydrogen. And then O is for oxygen. So again, oxygen does not exist as a single oxygen atom, instead it's two oxygen atoms together. Then you have fluorine and bromine and iodine, nitrogen, and finally chlorine. So 7 diatomics. They exist in a pair of atoms when they are not in a compound. So once you have all the formulas written out, then you would want to balance it, and some helpful balancing tips would be to balance the polyatomic ion that shows up on both sides of the arrow as a single unit instead of breaking them up. Balance one atom at a time, and if you save hydrogen and oxygen to last, it tends to be easier to balance. Now there's an occasion that we might want to use a 0.5 as our coefficient, but then you have to multiply all the coefficients by 2, because you can't have half of a molecule. So let's look at an example. Here we have a word equation. Calcium chloride reacts with silver nitrate to produce calcium nitrate and silver chloride. So let's pick out some key words here. To produce would be my arrow or my yield sign, showing that I'm going from the reactants to the products. So anything that comes before that arrow is a reactant, anything that comes after that would be a product. Reacts with would be a plus sign, and would be a plus sign. Then I just have to figure out what these compounds are. So calcium chloride. Calcium is Ca with a charge of +2 because it's in group 2. Chloride is chlorine, so it's in group 17, so it has a -1 charge. So when I cross the charges, when I bring those numbers to the opposite, I would get a formula of CaCl2. Reacts with is my plus sign, and then I have silver nitrate. So silver is Ag, and it always has a charge of +1. Nitrate is a polyatomic because it ends in ATE. So we look on page 7, and that is NO3 -1. So when I cross my charges, I get AgNO3. Then there's my arrow. And then I have calcium. It's still in group 2, so it has a charge of +2. Nitrate on page 7 is still NO3 1 minus, so I cross my charges, CaNO3 2, and silver is Ag with a +1 charge, and then chloride is still Cl with a -1 charge, so that would be AgCl. Okay, so now we need to balance this by adding in coefficients. Coefficients are the big numbers that we put in front of our compounds. I don't know why, there it goes. In front of our compounds so that we can balance. I think it's the easiest to start balancing using the inventory method. So before we start balancing, we're going to take our arrow and we're going to draw a line down our paper so we can list how many of each we have. And then we're just going to go compound by compound. So we have 1 calcium, 2 chlorines, 1 silver, and then I have NO3. Notice NO3 is also on the product side. So we're going to treat that as one thing. We're not going to separate the nitrogen and oxygen. So NO3, we have 1 NO3. And then when we come to the other side of the arrow, we have 1 calcium, 2 NO3s, 1 silver, and 1 chlorine. So to balance this, we have to look to see what's not the same. And so the first thing I notice is we have 1 calcium on both sides, so that's balanced. We have 2 chlorines on the left, but only 1 chlorine on the right. So we have to put a coefficient in, and the coefficient is going to be multiplied by the subscripts. So I take the smaller value, which is 1, and what can I multiply it by to make it equal to the bigger value? So if I put a coefficient of 2 there, I'm doubling everything in this compound. So 2 times 1, 2 times 1. So now my chlorines match. Calcium matches 1 and 1. Chlorine matches 2 and 2. So now I'm going to move on to my silver. 1 Ag, 2 Ag. So again, I'm going to go to the smaller value, which is 1, and I'm going to multiply in order to make it equal to the bigger value. So I would put a 2 as my coefficient, and then everything in that compound gets multiplied by 2. So 2 times 1, 2 times 1. So I have 2 silvers, and then 2 NO3s, 2 NO3s. So now we're balanced. So the coefficients then that are in front of the 2 lines that are blank would be the number 1. We just don't tend to write the number 1 because 1s are understood. So the coefficients for this balanced equation would be 1, 2, 1, 2. 1, 2, 1, 2.